So we're going to have a go at part B of question 3 on the November 2019 P2 paper. So we need to have a look at what it's asking for. It wants a term independent of x. So when we expand these two, we multiply them out. We're wanting the terms that basically have x to the power 0. And that's a bit of a clue of what we're going to need to do. So if we look at this section first, I'm going to rewrite that, and I'm actually going to do this as a grid multiplication. Okay. So we're going to have our grid over here, and I think on the left hand side, if we tidy up, as I say, if I tidy up the x squared plus 8 over x to the 5, you can hopefully agree that x squared over x5 gives us x to the minus 3, and then the next bit is 8x to the minus 5. So this whole section on the left hand side would be, let's just call that A. That would be that A bit there. You've actually done quite a lot of the work in part A for the expansion of power 12. Let's just start writing out a little bit of it. I'll write it out a little bit small if I can. So this is all just taken from part A. Okay. I've left a little bit of space at the side. We'll come to that in a minute. That was x cubed. Now, if I was to multiply this out, and I'm not going to bother with all of it, because I want the ones that don't have an x in it, well, this would give me something with an x in it. This would give me something with an x in it. This would give me something with an x in it. But however, this would not. The x to the minus 3 would cancel with this, and I'd end up with 55 over 16. So I'll just leave that there for the moment. The next section, well, okay, I don't need to do that because that would give me a power of x, and so would that, and so would that, and so would that. But if we were to continue this a little bit further, well, which one are we looking for? Well, we're looking for the term that would cancel with x to the minus 5. And so far, our expansion stopped at x cubed, but there was a pattern going on here as well, wasn't there? So if we think of this pattern here, I'm looking at this section now. As we go with the ones, they drop down, and the powers, say, for example, here 9. Ooh, I missed that there completely. That 9 and that 3 add together to give you 12, and so on. So we can just use that because we want a power 5 over here, don't we? And we also, if we notice that this matches with this on every single one of them, that's kind of why we did that table. So hopefully it shouldn't take too much to think of it to realise that what we're looking for is we want 8, let's take that 8 here, multiplied, I'm just thinking of the coefficients. So I want 12, choose 5. I can put the 1 in if we need, not that that's going to do much to answer. And then x over 4 to the power 5. Right, that's a little bit untidy. So if we multiply out all of this, I'm going to go on to the next page now. They've given us 2 pages for a reason. Then I'll just tidy that up. So I've got 8 multiplied by, well, 12, choose 5, actually gives us 792. And then we mustn't forget as well that we are multiplying by, and we look at the numbers in front of it, the coefficients, so I don't need to bother with this x to the power 5, because the whole idea is it cancels out. So now I've got times by 1 over 4 to the power 5 here. Right, so on the next line, I've got 8 multiplied by 792 multiplied by 1 over 1024, which comes out at 99 over 16. Okay, so we've nearly finished with our question here. What we need to be doing now is just tidying that up a little bit. So we've got this 99 over 16, which is going to be one of our terms. So let's have a look. So we're looking for the term independent of x. So we want to, let me rub that equals out. So we want to do 99 over 16 plus our 55/16. And this should give us the term that is independent of x. So add those two together and we end up with 77. It cancels down over 8 if my calculator is correct. So there we are, that is the term that is independent of x in this question.